Here's a problem from homework number 16. It says, in a Research Institute poll, asked respondents if they felt vulnerable to identity theft. In the poll, 913 people were asked and 595 said yes. We need to use a 99% confidence level to find the confidence interval. Confidence interval, that's what we need to find here. Find that, okay? So what do we need to find to do all this? Well, if we refer back to the formulas that we had previously, we are focused here on population proportion on the left. And remember the population percentage, the true population percentage lies between the sample population percentage and plus or minus the error. And the formula for the error is there, and those are all the parts that we need to find: the sample percentage, the Q, the sample size, the critical value, and then ultimately we will find the error. So let's go back here to the question, and we'll figure out all these parts. So we need to find P hat, we need Q hat, we need to know N, we need to know the critical value, and ultimately we need to be able to find the error. Okay, some of these we know straight off the bat, like N. We were told that 913 people were asked. Out of those, we were told that 595 said yes. So that's our probability of a success. So we can find this sample percentage right up here. It's going to be the people who said yes out of the total number of people asked. And if you do that on your calculator, you're going to get P hat of 0.652. Okay. Well, we know that Q is always 1 minus P hat, so that is going to equal 0.348. Right. The next thing we need to do is find this critical value. All right, so we're talking about a 99% confidence. All right, so let's go to another slide to figure that value out. Okay, so I've set this up. In this case, our confidence level is 99%. Okay, so we're 99% under here, and that leaves just a very small percent outside of this area. This is 0.9900. And remember then alpha over 2, the area outside, is equal to 1 minus the 0.99, what's inside, divided by 2, because these are broken up into two equal parts over here and over here. All right, so if you work all that out on your calculator, you're going to get 0.0050. In other words, it's just 0.5% in each side, 0.05. It's just 0.5%, or as a decimal, 0.0050. Very, very little bit here. Same thing, 0.0050, 0.5%. Because as you can see, there's only 1% left, and then it gets divided into 2. All right. From there, as you know, we go to our Z table and we look up that 0.0050. And let's shut that off. 0.0050. Well, look, they actually give us a dot because 99% confidence level is also a pretty common one. It's right here halfway between 0.0051 and 0.0049. So we can see this confidence level is negative 2.575. Negative 2.575 is the critical value, the Z score for that. All right, so let's go back to our table here, and we'll write that in. Z is equal to negative 2.575 on this side and positive 2.575 on the positive side. And it makes sense this would be so big because this is 99% under here. So these critical values are pretty far out. Here's the critical value and the critical value. All right, and this is the one we're interested in for our problem. So let's close this out and go back to the original problem. Okay. All right, so writing this in here, the critical value we now know to be, we now know to 2.575. All right, so that just leaves us to find the error. And the formula for finding the error for a population proportion is, just quickly review, the critical value, times the square root of p hat q hat over n. All right, let's plug all that in. 2.575 times the square root of our 0.652 times 0.348. Be careful, this is all under the square root sign, so you want to do all this in your calculator first. 0.652 times 0.348, enter, divided by the 913 equals, then you want to square root that and multiply it by the 2.575. And you should spit out on your calculator a value of 0.0406. All right. So in the end, switch colors here, our true population is going to lie, our true percentage of people who feel that they're vulnerable to identity theft is going to lie between the p hat, which is our sample probability, 0.652, plus this error of 0.0406, just about 4%, and the 0.652 minus that 4%. All right, so the true percentage is going to lie between 0.693 and 0.611. All right, so in the end, if you really wanted to think about what that means, it basically means that the percentage of people in the population who are worried about, who feel vulnerable to identity theft, that true percentage lies somewhere between about 61% and 69%. All right, and you can conclude that with a 99% confidence. 99% confidence, which is a high level of confidence. All right, before we close this out, I just want to double check that you know how to check your work on StatCrunch. It's important to be able to know how to do both. So let's just quickly, you might want to pull out those StatCrunch tips. Open up yourself a StatCrunch, and you'll notice here that you click on Stat, there's something called Proportion Stats, just one sample, and in this case, we were given with summary. We can do this actually with raw data too. And if you remember, the number of successes in this problem was 595. People said yes, out of a total number of 913 people. Okay. And the default is here on the hypothesis test. We'll get to that later, but we want to click on confidence intervals. That's what we're doing here. And the default confidence level will always be 95%, so we're just going to change that here to a 99% confidence. We'll go ahead and click compute. And there you go. There's that upper limit right here of 0.611, or the lower limit, I'm sorry, and the upper limit of 0.692. So sometimes those are going to be off by, a 10,000th of a place. But if you're running into trouble with your homework because of small errors, always check your work with StatCrunch. Okay, so go ahead and give that a try.